Welcome to the GRAPHISOFT Tekla joint presentation. In this presentation, you'll discover how architects and engineers can exchange building design information, share and manage changes, and create professional, fully integrated construction documentation. GRAPHISOFT ArchiCAD. GRAPHISOFT was founded in 1982, over 25 years ago. ArchiCAD 1.0 previously implemented the virtual building concept. Today, this is known as BIM, that is, Building Information Modeling. Virtual building, or BIM, projects are better designed, more predictable to construct, and less expensive to operate. Over the last 25 years, over 1 million building projects worldwide have been designed and realized using ArchiCAD. GRAPHISOFT is represented worldwide, and ArchiCAD is distributed in 102 countries, is available in 17 languages, and in 25 localized versions. ArchiCAD runs on both Microsoft Windows as well as Apple Macintosh operating systems. We put great effort in providing a high-end software solution for design professionals. ArchiCAD provides fully integrated building information modeling, design evaluation, and documentation workflow. Designers using a true BIM, Building Information Modeling, software solution and workflow, will need less time to complete an architectural project. The project will be more consistent than a project using 2D tools. The documentation and coordination issues become almost automatic procedures, and the overall time to market is shorter. Collaboration with engineers will be easier, smoother, and more productive. Throughout this presentation, we will focus on how designers can work together with engineers and present the design workflow between architects using GRAPHISOFT ArchiCAD and structural engineers using Tekla Structures. Tekla Structures. Tekla Corporation develops and markets software products and related services that make customers' core business processes more effective, enable their further development, and enhance customers' competitiveness. Tekla software products are used in building and construction, energy distribution, and infrastructure management. Tekla Corporation was established in 1966 and has been listed in the Helsinki Stock Exchange since the year 2000. We employ over 460 professionals globally. Our net sales were over 60 million euros. Over 80% of this sum came from the global market. Tekla software products are sold in the international market to clearly defined customer segments and are meant for professional use. Tekla Corporation is also a global company. We have offices in 14 countries, have over 30 independent resellers and partner firms, and have customers in over 90 countries around the globe. Tekla software products are available in 13 language versions and in over 30 localized environments for engineers. The ingenuity of Tekla's products is in their model-based technology, and Tekla is an international forerunner in this field. Tekla has decades of experience in select customer industries. Tekla Structures is the first building information modeling, or BIM, software covering the entire structural design process from conceptual design to detailing, fabrication, and construction, as well as the planning and management of fabrication and construction from the structural side. In this presentation, we will focus on the architectural integration and on the site management collaboration aspects of Tekla Structures. Open-BIM concept. Structural applications have at least one of the following primary functions. Modeling. Modeling applications create the engineering model based on the architectural reference model. This model serves as the basis for analytical and detailing applications. Analysis. Analytical applications do stress displacement calculations. The results will then serve as the basis of the steel reinforced concrete or timber design. Detailing. Detailing applications develop reinforcement drawings, steel detailing, and usually connect to manufacturing applications such as CNC machines. Tekla Structures is an engineering and multi-material modeling application and provides a complete solution for general contractors. It has both structural modeling and detailing functionality. Tekla also establishes an open, direct interface to connect to local and major analytical applications. The reference model concept is the most important workflow concept used throughout model export and import, as well as change management. Each discipline is responsible for the creation and development of its own model. Reference model means that a discipline, let's say the structural engineer, uses the model of the architectural design for the initial basis of creating the structural model. The structural model will be created as a standalone model, yet some initial design information will be taken from the architectural model. Version tracking or change management can be done for the reference model versions of the various disciplines throughout the design workflow. Different disciplines, such as architectural and structural, use different design concepts and manners to create their own models. Let's see a quick example to demonstrate the major differences between the modeling concepts of the two disciplines. The architect designs a two-story column as a single continuous column element in the architectural design. The structural engineer will define two separate structural column members in such a design case. Both the analytical and detailing applications need to consider two separate columns as well. Slabs are also handled in different manners by the disciplines. Architects typically create one single slab that spans across an entire story. Structural engineers divide the single slab into units to comply with various structural requirements and define, for example, hollow core concrete panels. IFC is an open, intelligent, object-oriented file format. It's used industry-wide as the common platform to exchange building information modeling data between AEC applications for the entire life cycle of the building. Let's review some of the IFC benefits. IFC supports the reference model concept. IFC provides 3D geometry representation for all project elements. IFC also stores standard and custom data about each element, such as materials, profiles, functions, and so on. The applications used by the disciplines can be easily and quickly filtered and identify relevant discipline-specific information from the IFC database. IFC is an open standard. All software vendors can build on it or develop it. IFC is used industry-wide as the common platform to exchange building information modeling data between AEC applications for the entire life cycle of the building. GRAPHISOFT and Tekla are members of the Building Smart Association. Both companies have already proven their commitment to open IFC-based BIM collaboration, and they both have the highest IFC certification level. Using IFC for the basis of BIM collaboration, in actuality, means that designers and engineers can collaborate safely and efficiently with other disciplines using other software. On this side, you can see a collection of design, analytical, structural, mechanical, engineering, plumbing, fabrication, as well as project and construction management applications that ArchiCAD and Tekla users can connect to via IFC or other exchange file formats. ArchiCAD Tekla Structures Workflow. Before starting the applications, let us briefly overview the main steps of the GRAPHISOFT ArchiCAD and Tekla Structures building design workflow. 1. Let's start with the architectural model. Architects create the first model according to the client's request in the given site. 2. To prepare the model export, architects can filter the structural elements by using element classification, layers, layer combinations, display settings, selection modes, and so on. Of course, the whole building without any filtering can be exported as well. 3. Architects export the filtered model in IFC file format. 4. Engineers receive the architectural model and insert it as a reference. The complete model or elements of selected architectural layers can be imported. 5. Engineers define the structural model and its details based on the referenced architectural model. They can also generate analytical models for analysis applications. Engineers can query the initial profiles and materials defined by the architects. Real Tekla elements can be converted from the referenced beams and columns with the Tekla Object Convert tool. 6. The ready structural model or a filtered part of it can be exported back to the architects. 7. Engineers also use IFC file format for the model exchange. 8. There are two possible ways architects can import an IFC file. They can merge the structural model into the current architectural project, or they can open it as a totally new file. Filtering is also available for the import, and imported elements can be placed on given layers. By default, the new imported elements are set to be protected according to the reference model concept. Architects may compare two view sets. One contains the architectural model, and the other contains the imported structural model. They can use the Trace and Reference tool to aid the comparison of the floor plan and section views. Architects can query the profiles and materials decided on by the engineers. 9. Architects can modify their project according to the imported reference model, or they can accept imported elements by using them as real ArchiCAD type elements. 10. They can export a new IFC file based on the project's new status. 11. The new architectural model can be imported to the current Tekla model as a reference mentioned previously. 12. The new imported model can be compared with the old architectural reference. The new, deleted, changed, and unchanged elements can be displayed on the screen beside the real structural model. 13. Engineers can make changes in the project according to the results of the comparison process. 14. And engineers send the new structural model version back to the ArchiCAD user. 15. The new IFC file received in ArchiCAD can be compared with the previous structural version. The result of the comparison is listed before merging it into the current running architectural project. 16. The comparison process automatically merges the detected changes only, so the new, modified, and deleted elements will be included as a reference in the architect's running project. 17. Architects can easily check the changes recommended by the structural engineer and can make modifications to update the design manually or by using structural elements as real ArchiCAD elements. Both engineers and architects can repeat the previously mentioned model exchange, comparisons, and updates in additional cycles. Finally, the two disciplines make their own or combined documentations. Let's see the previously described workflow in practice. We will be using a 10,500 square meter office building in our presentation. Exporting the design from ArchiCAD. Let's start with the architectural design model developed in ArchiCAD. For the given site, architects create a design development building model. Let's have a closer view of the building without the environment in the 3D window. Let's filter the elements in the 3D window and display only the slabs of the project. This can be done in seconds with the help of the Find and Select dialog. If we have a closer look at the elements in the 3D window, we will notice that not only the load-bearing slabs, but also the suspended ceilings are displayed. By mistake, the architect did not use the appropriate element classification for the suspended ceilings. So let's correct this now. We will select all the suspended ceiling elements with the help of Find and Select, and then we will modify their element classification. Let's have a closer look at the Listing and Labeling tab page of the Selection Setting dialog. First, let's choose Ceiling for the IFC element type. Let's also select the non-load-bearing element option for structural function. With these modifications, we have ensured that all ceiling elements in the project are classified as non-load-bearing ceiling elements. Let's display the entire architectural project model again in the 3D window. Now we would like to display the interior elements only. All we need to do is to activate the Find and Select dialog and select elements classified as interior by their position classification. As you can see, only the interior elements, including the previously modified suspending ceiling elements, are visible in the 3D window. Let's now display only the exterior elements. We can do this in the very same manner as before. As you can see, this time, only the building exterior is displayed in the 3D view. Let's have a closer look at the entrance atrium of the office building. As you can see, this atrium has some steel beams and columns. These steel elements have all been created using standard steel profiles. This is very important since Tekla Structures also uses standard profiles, and these standard steel elements exported from ArchiCAD can be converted to same type native steel elements in Tekla thanks to its Object Converter tool. Let's select a steel column and open its Settings dialog. As you can see, the profile of the selected steel column was defined as complex structure by using a Eurocode standard steel profile called IPE 200. ArchiCAD enables designers to access thousands of standard steel profiles from a worldwide industry profile database right out of the box. These steel profiles can then be used when placing columns or beams. The Standard Steel Profile Database dialog helps you select the necessary country code, identify the required profile shape, and its sizes. We are free to select any of the listed profiles. All the selected profiles can then be added to the project with a single click. Let's open the Column Selection Settings dialog again. Please notice that all the previously imported standard steel profiles are available and can be used instantly. As a result, during the data exchange process, structural engineering programs will recognize and identify such standard elements accurately and completely without requiring any adjustments to the settings. With the help of layers and layer combinations, we can store and display the elements having a structural function like load-bearing walls, slabs, columns, beams, roofs, and so on, separately from the other project elements. Please notice that all the structural layers of the project are included in the structural bearing layer combination. Let's activate this layer combination to display only the structural layers in the 3D window. Now, let's go back to the entire architectural model and open a section view. As you can see, this view currently displays a wall slab detail. All the composite elements with all their layers, as well as the non-load-bearing ceiling elements, are displayed. Let's now activate the Partial Structure Display dialog to filter the display of elements in the section view. We will select the Core of Load-Bearing Elements Only option. This will ensure that only the elements classified as load-bearing by their function and the core part of composite structures will be displayed. This is also valid for the 3D view of the project. Let's bring up Partial Structure Display again and choose the Core of Load-Bearing Elements Only display mode for the current 3D window. Thanks to the function classification, the Partial Structure Display feature enables designers to simplify the entire model to just the load-bearing part of the model with only one click. We will export the IFC database using the elements in the 3D window, and we will send this file to the structural engineer. We can export and send the entire load-bearing structure visible in the current view, or we can filter the exported file by creating a selection set for the export. For instance, we can use the Find and Select dialog to select all the elements on the steel frame layer. As you can see, all the steel frames are selected in the 3D window. We can use a 3D project view or a floor plan view to create such selection sets. Let's activate the File, Save As command. Please note that ArchiCAD supports IFC, IFC XML, as well as their compressed zip file formats. The compressed IFC file formats are handy when dealing with large projects. Now, let's select the IFC zip compressed file format. Please also note the various export options. As mentioned earlier, we can export the selected elements only, the entire project, independent from the visible content of the current view used for the export, or the visible elements on all stories option. Choosing the last export option, only the visible elements of the 3D view will be exported independently from the applied selection set. For the export translator, we will select one called Data Exchange with Tekla Structures, which is optimized to exchange models with the structural engineer using Tekla Structures. After entering a file name, we can click the Save button to proceed. ArchiCAD will export the IFC project with the previously defined specifications. Importing the design to Tekla Structures. Let's see how the structural engineer using Tekla Structures can open the previously saved architectural model and create the structural model. We will insert the architectural model as a reference model. The reference model can be used to overlay the architectural model with the engineer's own model. At the Reference Model Properties dialog, we will select the previously created IFC file. Please note that Tekla Structures also supports all the IFC file formats, including compressed IFC formats. The engineer can filter the IFC data and select only specific layers to consider. The previously created and exported ArchiCAD layers are visible here and can be used perfectly to filter the IFC data to be used throughout the structural design. As you can see, Tekla Structures opened the architectural model perfectly. Let's focus on the steel structures of the entrance atrium. Engineers check the properties of reference objects defined by the architect with the Inquire tool. Let's use the Select Objects in Components command to pick the elements of the reference model and query their properties. Here you can see that the selected steel element was created by ArchiCAD. It was classified as external use and as a load-bearing element. It's generic steel, and its profile name is IPE200. Let's create some clip planes to focus on a specific part of the building model. It will be helpful to focus on just the part of the model where we wish to continue working. We will create 2 clip planes and position them so the steel structure of the entrance atrium will be in the center of the 3D view. Let's continue and create the structural model based on the reference model. Tekla provides various tools to help this work. The referenced steel columns, beams, and bars can be converted to native Tekla Structures elements with the help of the Object Converter. After selecting the steel elements in the reference model, we can run the IFC Object Converter from the Macros dialog. The Object Converter generates new steel beams and columns according to the imported IFC profiles and the tool's available profile database. The newly created native Tekla steel elements are displayed in blue. Let's have a closer look at the properties of these newly created steel elements. As you can see in the Beam Properties dialog, the profile name of the steel elements is IPE 200, and their material is set to generic steel. Let's edit the material and, for example, select a Eurocode steel grade from the Select Material dialog. Let's continue and select one of the steel columns. At the Column Properties dialog, we'll modify the steel profile of this column. Let's select HEB 200 for the new standard profile. Let's also change the steel material of this column with the help of the material database. We will create a new concrete beam based on the geometry of the architectural reference model. Let's start by defining the properties of the concrete beam. Let's set the height as well as width values of the concrete cross-section. Let's also select a standard concrete grade for the new beam. We can also set the position and the location of the reference line of the concrete beam if necessary. The position of the reference line will define the start and end point of the new beam according to the referenced one. Finally, let's proceed and create the new beam with the previously defined properties. As you can see, the newly created concrete beam is indicated in yellow in the 3D window. Let's continue and create a new concrete wall panel. We can start by setting the shape, as well as the material attributes of the wall panel if we wish. Let's create a new concrete wall panel with the help of the reference model. However, this time, we will create a higher wall panel than modeled in the reference model. Let's continue the work and add structural details to the design. We can use Tekla's component catalog to start. This catalog already contains numerous predefined structural detail templates. However, we can also create new ones if necessary. Let's select Favorites for now, in which the most frequently used components and company standards can be collected. Let's select a steel column, steel beam component from the Favorites, and apply this to the project. As you can see, the result is immediately visible in the 3D view. Let's select a clip angle from the component favorite. We will add this to the junction of the steel beam and the concrete beam at the top of the atrium. As you can see, the new structural detail is instantly visible in 3D. Let's select a base plate in the component catalog. We will apply this at the junction of the steel columns and the concrete wall underneath. Let's review the parameters of this component. Tekla Structures provides various customizable properties for all components. We can freely edit all the dimensions of the component parts. Let's proceed and add the base plate component to the project. Let's select the wall panel reinforcement component from the catalog. We will apply this component to place reinforcement mesh into the concrete wall panel below the steel columns. The structural engineer continues the work. Here you can see the completed structural model of the atrium entrance. Please note the level as well as the precision of the structural details. Even the reinforcement bars are visible in the reinforced concrete structures. Let's hide the architectural reference model for now to get a clear view of the structural design. We will select and export the structural model of the atrium in IFC format and send it back to the architect. At the Tekla Structures IFC export dialog, we can fine-tune and define the IFC characteristics of the exported data. We can select the compressed IFC file format. We can decide if we wish to include the previously created assemblies, bolts, or reinforcing bars in the exported IFC file. merging the structural model to ArchiCAD. Let's switch to ArchiCAD and merge the structural model to the architectural project. The IFC file received from Tekla Structures can be opened as a new project, or can be merged into a running architectural project. Let's see how the architects can merge the structural IFC model to their own running project. Set the file type to IFC compressed file and browse for the IFC file created by the structural engineer. At the translator, specify the data exchange with Tekla Structures translator file. Let's open the settings dialog of this translator to briefly review its characteristics. At the Import Options page of the Translator Setup dialog, we can define the layers we wish to use when merging the structural elements. The default settings of the selected translator add the Tekla extension to the layer names where we merge the structural elements. By default, the layers are locked to be protected against further accidental changes. We can also use custom material conversion tables when merging the structural elements. The Conversion Table dialog displays how the materials defined in Tekla Structures will be converted to ArchiCAD fill types by default. Of course, the conversion table can be edited and customized for our current ArchiCAD project. Let's continue the merging process by clicking Open. The Model Filter dialog will be displayed automatically. Here we can filter the imported structural model. For instance, with columns, we can filter the column types we wish to merge to the project and so on. We will merge all elements and element types in our case. ArchiCAD will merge the structural elements. Let's have a look at the results in the 3D window. Let's open the Layer Settings dialog. We will display all architectural elements in wireframe mode, and all imported structural elements located on the locked layer with the Tekla extension in shaded mode. Let's have a closer look at the entrance atrium which was created in Tekla Structures. As you can see, the horizontal steel beam is an IPE 200 standard section. The vertical steel column is the modified HEB 200 profile, as we defined in Tekla Structures. Please note that all the steel structural details and components are clearly visible in ArchiCAD. The material specifications are also correctly merged with the structural design. Let's select the concrete wall panel. Open its settings dialog. Please note that due to the previously defined material conversion, the name of the structural material corresponds to the material name defined in Tekla Structures. But the cut fill of this material has changed to the ArchiCAD fill, as defined at the Material Conversion dialog. Let's make the reinforced concrete structures transparent for now, so that we can have a close look at the reinforcing bars created in Tekla Structures. Let's display the entrance atrium in a section view in ArchiCAD. Let's display the previously merged structural design as a trace reference in this section view. We can change the color of the traced elements if we wish. ArchiCAD's virtual trace features enable designers to simultaneously view and visually compare elements of the active and traced views. In this way, even the smallest differences can be easily spotted and quickly identified. Here we can see the architectural model as the active view and the merged structural design as the traced view. Tracking changes. Let's briefly explore how the architect and the structural engineer can identify and manage changes in the different design models. First, the architect will modify the design in ArchiCAD. Let's delete the middle steel beam and column at the entrance atrium. We will also modify the position of the next steel frame. We will drag both the steel column and beam 1,500 millimeters. Finally, we will export the updated architectural design as an IFC database and send it to the structural engineer. Let's switch to Tekla Structures now. The structural engineer can compare the new and old versions of the architectural model. The engineers can insert the changed architectural model as a reference into the running structural project, as introduced earlier. Let's browse for the new IFC file and place it into the structural project. The newly imported elements are shown in dark colors. Now let's browse for the IFC file representing the latest stage of the design and compare this with the previous stage. At the Change Detection page of the Reference Model Properties dialog, we have various options. From a drop-down list, we can select what to display on the screen regarding the results of the comparison. We can select to show only the new file or the old file, or display the unchanged, changed, deleted, or inserted new elements. Now we will display only the deleted elements first. As you can see, only the middle steel frame is now displayed on the screen, which was deleted by the architect earlier. Let's display the changed elements now. As you can see, the other steel frame that was moved by the architect is now displayed. Finally, let's display the new file, only to see how the updated architectural design looks. Let's continue and update the structural design based on the inserted architectural reference model that displays the latest design stage. First, we will delete the middle steel frame in the structural model. Then, we will modify the position of the other steel frame. The new position of this frame will be based on the frame in the architectural reference model. Finally, we will also place a new horizontal steel beam in the structural project as a suggestion to give the correct stiffness of the modified state. We will select, for example, a Eurocode standard HEA 600 steel profile from the database. The new horizontal steel beam will be placed at the junction of the existing steel columns and beams. Let's now export the updated structural design in IFC file format and send it to the architect. Let's switch to ArchiCAD now and see how the architect can manage the structural design changes. We will activate now the File, File Special, IFC 2x3, Detect IFC Model Changes menu command. The IFC Change Detection Wizard will guide us through the necessary steps. First, we have to specify the old version of the structural model. Then, we also have to specify the new version of the structural model. We can define the elements we wish to compare in the change detection process. For now, we will compare all element types. As you can see, ArchiCAD already displays the number of new, modified, and deleted elements prior to merging the IFC model changes to just the current architectural project. Here we can also specify layers we wish to use to merge the compared version elements. Finally, we can click the Merge button to proceed. In just a few seconds, ArchiCAD will merge only the changes of the IFC model versions and display the Markup Tools palette. This palette already lists all the model changes with color codes. Let's select the first entry in the markup list. This is a new element and it's identified in blue. We can zoom in to this element. As you can see, this is the horizontal steel beam created earlier by the structural engineer. Let's select the second deleted element indicated in red. This is the middle steel column which has been deleted from the project. Let's delete this markup entry. ArchiCAD will offer to delete the corresponding elements with the markup entry. Let's select and delete the next markup entry, representing the deleted middle steel beam. Let's select the next modified steel column elements shown in green. Let's zoom in and select these modified columns. When we hover the mouse over the selected columns, ArchiCAD will display the layer of the selected element in the Info tag. The column placed on the IFC imported old layer represents the previous position of the column. The column placed on the IFC imported new displays the new position of the column. Based on this information, we can decide on the next design steps. As you can see, GRAPHISOFT ArchiCAD and Tekla Structures provide a complete, integrated, best-in-class design workflow. ArchiCAD and Tekla Structures together bridge the different requirements for the BIM models of architects and engineers and realizes the Open-BIM approach for this practice, greatly broadening designers' options for real integrated project delivery. Reference projects. Let's briefly overview some actual projects where architects and engineers implemented this IFC-based Open-BIM collaboration design workflow in their architecture practice. The Panorama Tower Office Center has been designed by Larkus and Lane architects and realized in Espoo, a city close to Helsinki, Finland. The office center consists of 3 building masses that are connected to each other. The total floor area is over 22,000 square meters. That's over 235,000 square feet. Here you can see some photos of the realized tower. Here you can see the Tekla Structures model of the Panorama Tower on the left. This 3D model presents the precast and steel structural elements. On the right side, you can see the architectural design model created in GRAPHISOFT ArchiCAD. This project model presents all the architectural elements and aspects of the tower. Both are true BIM models, including a very high level of detail about the information they present. Here you can see the combined architectural and structural building information as one single model file. It's important to emphasize that even though both architectural and structural models contain a high level of detail, the file size of the model remains small and therefore very manageable as one single project file. Let's take a very quick look at some other projects as well. All these projects have been designed by other architectural and engineering teams, but they all share some common aspects. The architects use GRAPHISOFT ArchiCAD to create and develop the architectural design, and the structural engineers used Tekla Structures to create the structural schemes. The architectural and structural teams implemented the previously described IFC-based Open-BIM collaboration workflow. Vierumäki Congress Center is located next to Finland's largest sports academy. The center hosts over 400,000 people per year. Peru provided the design development as a Peru integrated design and delivery service from the early sketches to the full BIM model. The total time from planning to ready building on site took less than 18 months. The in-house merged model served as essential aid for multidiscipline design coordination. Finland's pavilion for the Shanghai World Expo 2010 is called Kirnu, or Giant's Kettle. The Kirnu Pavilion is a laboratory for sustainable building, presenting finished solutions for future urban construction. The construction materials and methods have been selected so that construction generates as few greenhouse gas emissions as possible, and the building will be easy to disassemble and rebuild after the expo. We hope that you found this presentation useful and that you'll share the opinion of architects and engineers. Open-BIM collaboration is the future of the AEC industry. Thank you for taking the time to watch this presentation.